Hey everyone, it's great to be here. Thanks for joining us, and to our virtual people. I'm looking at the cameras. Good morning, good afternoon, good evening, wherever you're joining us from. How's everyone today? How's everyone today? It feels like everyone had a heavy lunch. Okay. Okay, we'll get started. This is one of my favorite tools at H2O. We build an array of tools, as you all know. And I'll just do a quick poll by raise of hands. How many of you are familiar with deep learning techniques or deep learning terminology? Okay, a fair mix. And how many of you do you Kaggle? Has anyone Kaggled here? Okay, a few. And do you use these deep learning models at work every day? Okay, a few. So you're at the right talk, because this tool is supposed to help you with all of that. H2O's Hydrogen Torch is the next framework in our lines of, or in our armor of software that we built. And as you know, we're home to many Kaggle Grandmasters, many in the top 10 rankings. And fun fact, we are home to Kagglers who have been #1. So many people have reached #1 in competitions, which is the hardest category possible. And now us as a company, what we're trying to do is we're trying to package their brains into softwares that we want to send to you in just an app store that you can simply run off of a browser. So for today's talk, I'll be talking about Hydrogen Torch and the different things it allows, along with a short demo. So I'll try to run through my slides. If it feels rushed, I'm just giving you an overview, and the demo might be more interesting for everyone. I guess that's what we're here for. A quick word about our community. I lead our community efforts. So if you're interested in talking more with our grandmasters or hanging out and just connecting with people, you can head over to Discord, or you can join community.h2o.ai. Once again, that's community.h2o.ai. Few words about me. As Phil said, I'm a Kaggle Grandmaster, only in discussion. So as you can imagine, I talk more than building our products. I build content around our community, and I'm helping grow our community. I also have a well-known podcast called Chai Time Data Science. So if you want to know more about our Grandmasters, you can check that out. Hydrogen Torch allows a few things. The next big thing in machine learning, I feel, is unstructured data, because we by definition have much more images on our phone. The internet largely is comprised of text, and deep learning is just now starting to pick up its power in production or in real world. So Hydrogen Torch brings that power to you through the H2O AI App Store, and it helps you apply these models very easily and allows people with different levels of experience to put these models in production. So if you don't have a lot of field expertise in deep learning, but you have a lot of domain knowledge, as we saw earlier in the day, you can use this tool. There are different levels with which you can interact. It's also for experienced deep learning engineers. So let's say you want to really handhold the model and figure out what you want to build. You're also allowed to do that. This is a no-code framework, so it's largely a UI-based interaction. And there are different use cases that we support right now across text, images, audio, and we've just updated the medical image one as well, so that will be also shipping really soon. You can select the problem type, train the model, and then deploy it to production, just through the single framework. That's all Hydrogen Torch does, and I guess I could end my talk right here. But I'll give an overview of what it enables. So you can imagine that you have your own data which you can upload to the cloud. From there, you can select the problem type you want to work with. And then you can fine tune or kick off as many experiments you like. At the end of it, we also make it really easy to download these models in either a pickled format or in any format that you'd like to work with. Most of them, we work closely with our customers to support that. And then you can deploy them to production as well. So the supported problem types right now are as follows. Across text, images, and audio, we support the following. And I'll give a quick overview of all of these, just run through them before giving a demo of one or two. We can decide amongst ourselves what you all would like to see. But across text, as you can see, most of the text problems that we use machine learning for today is supported. Same for images as well, and we're just starting to build out our medical images support as well. So 3D CNNs for those of you that work with medical data. For audio data as well, we're shipping a bunch of features really soon, and we're always building on top of this. So this slide might be outdated in just a week. And as you expect from H2O, we work really close with our customers. So if there are requests, you can expect this list to be constantly updated. One thing I want to point out here is, as I mentioned earlier, we have this incredibly large, one of the largest, I think the largest Kaggle Grandmaster team. So when I say these problem types are supported, it's not that you can just upload your data and you can get a solution. You have all of the tricks that these grandmasters, the best of the best, have come up with through literally fighting a battle on the Kaggle leaderboard. And you have their insights and their secrets, their tricks coded into all of these solutions. So even as a junior data scientist, if you just kick off the simplest experiment possible, there's a high chance that your model would be quite accurate. And I invite everyone to try the demo out later, or just sign up on our cloud and try that out later on. So I'll give an overview of the different problem statements I just spoke about. In images, we support image classification and regression. You can think about this as predicting whether there's pneumonia in a chest X-ray sample or not, whether a landscape is from a certain country or not. You could count the sum of coins from the photos. You could also imagine you could deploy this in manufacturing. I'm trying to think of more use cases, but anywhere you need to detect or you need to classify an object inside an image, you could do that. For object detection, where you need to detect individual examples inside an image, that's also really easy to do. And as I mentioned earlier, we're always shipping the state-of-the-art models. So in the demo you'll later see, we have quite opinionated models that are supported. And these are again coming from the Grandmaster team, which thinks that these would be the best possible models for that example. You could work with semantic segmentation. So this is an example from one of the Kaggle competition called Caravana, where you need to cut out objects from the background. If you have the latest iOS update on your phone, it's mildly annoying, but if in the gallery you can tap on people and extract that and send that out as stickers. I found that interesting. I don't know about you all. And that is also semantic segmentation running on your phones. So that's another example. You could have instance segmentation, where you could segment out individual cars. So let's say you're trying to build a model to help the traffic authorities bill the toll taxes or something like that. That's also possible through Hydrogen Torch. You could do metric learning. So metric learning is used for comparing products or comparing similarity, doing a similarity check. In deep learning, you create these models that create hyper representations inside of them. Metric learning allows you to compare that. Now, you don't need the knowledge of that. Even with Hydrogen Torch, we usually always give suggestions, as you can expect with driverless AI. You might have seen that. And you can just run through the options and also build models for metric learning or comparing products, searching for photos of the same landmark. So even on our phones, when we're roaming around and we take a picture, and if you select a certain object, it shows up in the browser, or you can find details. That is metric learning running on your phone. For text data, we support a wide range of things as well, as I said earlier. So you could classify text, you could predict customer satisfaction through reviews, you could classify spammy words or not, and you could also have this across multi-languages. So that's also being built in right now. Did I lose my slides? Okay, we're back. Sorry about that. You can also do something known as token classification, where you can extract entities from individual sentences. So you're helping your model understand what's going on inside of the sentence. I'll start running through these because I'm just giving an overview, and we're all here for the demo, I assume. You could also do text span prediction. So you could find relevant information inside transcripts. I think this could be a startup idea, but with Hydrogen Torch, you could also build a simplify legal language thing. I know no one likes reading contracts. I don't, maybe you guys do, but you could also simplify those and you could really understand them. That's one possible use case you could try out with Hydrogen Torch. You could do sequence to sequence modeling, which means you could do translation or you could summarize text, as I said earlier. You could do metric learning, so similarity search for text as well, where you could compare fake reviews with real reviews. This is becoming more of a challenge as we come up with bots like bots that are powered by GPT-3 and the next generation of transformer-based models. For audio data, we also support a wide variety of use cases. So you could do simple classification or regression, where you could identify birds or sounds of birds out there in the wild. Our Grandmaster team has won many of these competitions, so you can imagine it's the best tricks being coded into these use cases. You could also recognize the sentiment of a conversation. And just to appreciate how hard of a problem this is, your model literally just sees that spectrogram at the end of the slide. So you just by using Hydrogen Torch, you can convert an audio recording, and it takes care of everything in the most optimal way and helps you understand the sentiment of the conversation. We care a lot about model interpretability as well, and we like to make it easier for you to understand what's going on inside the model. How do you make sure it's working as it should? So for text data, we allow you to visualize the most important words. So you can, as you can see, the different tabs, we'll take a closer look during the demo. But you can take a look at the insights from validation test sets, and you can see which are the most important words, or which are the examples that your model got the most wrong predictions on. So this could help understand your data as well. Maybe your data is mislabeled and maybe cuss words are marked as positive, which shouldn't be the case, or it could be for some examples. So you can take a deeper look and understand if things are working as they should, and you can iterate on it. For image data, you can get a GradCam visualization. So just to bring your attention to that, if you're not aware, this allows you to understand what your models are paying attention to. So you've just built these models using Hydrogen Torch. Now I'd like to understand what they're focusing on. So the heat maps you see, the funky images, and those weirdly colored areas apart from the blue is what the model is focusing on. So this looks like the right image, because if you're trying to classify flowers, you want your model to focus on the flowers and not the window. And you can also do these checks visually for image data to make sure things are working as they should. For audio data as well, you could take a look at the spectrograms and the GradCam visualization of that. So ideally, again, this is a subjective discussion, but your model should focus on the graphs. So believe it or not, those are graphs of the audio being converted to a spectrogram. And you can see that the model is indeed being triggered by that, and it's actually looking at that. And as I said earlier, it's very easy to deploy all of these models that you've built across different use cases. So either you could download your predictions if you just care about getting predictions on a new data set. You could just do that. You could download the scoring pipeline as well, which allows you to predict new data using any model in a Python environment. So you can take the scoring pipeline and deploy it in your own Python environment. Or you could deploy it to H2O ML ops, and you can just use a simple REST API request to get your predictions. So all you have to do for that is basically click those 3 buttons and everything will be okay. And as I've been constantly saying, we make it fairly easy to do all of these steps. So it's very well integrated into our ecosystem, especially for ML ops. It's really easy to deploy all of these models. So what I'll do now is I'll switch to a demo, and I'll quickly share my screen. Okay. Awesome. Is this visible in the back? Cool. So this is the home screen of Hydrogen Torch's interface. I have launched an instance from the App Store and I have the app ready to go here. Hopefully, this is a live demo, so hopefully nothing goes wrong. What this allows you to do is at the home screen, you can see the 3 steps that you care about. You can import the dataset, create an experiment, and you can also see the list of datasets that I've already imported. You can see the list of experiments that I've been working on, so I get a nice overview of what my validation matrix are looking like, what problem type was this on, what dataset was this from. And I'm personally a huge fan of the names that the experiments are given. So let's kick off an experiment now, and I'll go to importing a dataset. It's fairly easy to import datasets from any platform that you work with, which could be S3, Data Lake, Kaggle, or you could literally upload your model as well. So let's say if you wanted to import a Kaggle dataset, you could put in your username and you could put in your secret key, and that will get imported. Let's try a dataset from S3. Does anyone have any suggestions? Should we do semantic segmentation? Should we do image classification? Feel free to shout. Image? Okay, let's do semantic segmentation. So I'll import this dataset, and what's happening now is it's getting downloaded really fast. I wish I had that internet. Really fast to the instance. And it's been loaded for configuration. As you can see, HT already figured out the defaults. So I can select, I had already imported this, so it says number 1. It adds a number 1. It figured out the problem type is semantic segmentation. If it wasn't the correct one, I could click here, and these are all of the use cases that I just ran through, so I could select these. That looks correct. The data format is indeed in what Hydrogen Torch likes, and if you're curious about that, you can also look at the documentation, figure out what it likes, what it doesn't. The data frame has been picked up correctly as well, and the data folder looks correct. All of the other things look good to me. It's figured out all of the columns by itself, so we're good to continue. I'll hit continue. And from here, it will also perform a few sanity checks and show me the data set. So by sanity checks, I mean if you've worked with any form of image data, usually there are corrupt images, and you set your model to train overnight, and you suddenly realize it's not training and it crashed 2 hours into it. Usually that happens when you have corrupt images or things like that. So all of those sanity checks just made sure nothing like that is going to happen, so we can continue further. Now I can take a visual look here. So what I'm doing is I'm hovering my mouse over different things, and for this problem type, we're trying to find individual pieces of clothing. So it correctly identifies that yes, this is a coat, this is a shirt, these are pants. It identifies shoes as well. So we've loaded the data set in the correct fashion. I did a quick check. I'm happy with this. I'll hit continue. And now I can view all of the data sets. So what I'd like to do is I'd like to create an experiment. And we'll go ahead with our data set. I'm feeling brave today, so we'll go with master, and I'll ask all of you for suggestions. So the problem type looks correct to me, and this experiment is going to be called stylish era for some reason. The data frame folder has been picked correctly, and all of the other options are picked correctly. Should we train this on one fold or multiple folds? Sorry? We support 5 folds, so I can't think of a use case where you'd want 10 folds. Let's do 2 folds. I'll just go through the other options. We'd probably want to train on 15% of the data. So what's going on here is this is, as I mentioned earlier, completely no-code framework. And all of these options that I'm selecting through are literally the experiment that I'm hand-holding. And I've gone through the master settings. If you go through the novice settings, it's really easy. All of the defaults are baked in. But we're selecting what we want to kick off, and we can kick off multiple experiments just through this UI. We can increase the image size. I think we can make it 512 by 512. It is indeed 3 channel images, and we can switch the normalization strategy to maybe ImageNet. You can change the augmentation strategy as well. I'll enable mix up. What backbone should we use here? Any suggestions? I have very strong opinions about backbones I like. Okay, I'll pick my favorite then. Let's go with Efficient B5, and we'll use the architecture unit. So we're doing semantic segmentation, which requires a backbone and an architecture. So the architecture could be unit plus plus, and it basically is minute difference on how you shape the decoder and encoder and find nuances that I won't go into. I'll probably just go ahead with unit plus plus. The loss function looks good to me. The optimizer looks correct. So I think we're good to launch this experiment now. So I'll hit run experiment. And as you can see, I was training on 2 folds, not 10 folds. So it's queued these experiments already, and just in a few seconds you'll see that these get started, and you'll start seeing the insights from there. I'll refresh my screen. So what's going on now is, with those settings, these experiments have already started, and in a few seconds I'll be able to get the insights as the models are being trained. So I get an overview like so. This is a completed experiment, but I can get all of the charts of the matrix I care about. And you could also take a look at prediction insights, as I pointed out earlier. So this is an example of audio data. And I can see that the best examples were the following. I can't tell any difference here. And the worst examples were the following. So visually it looks like these images weren't just converted correctly. Oh no, the experiments failed. This is a live demo, as I mentioned earlier. So I'll try another experiment. Maybe it's something simpler, let's say image classification. And I'll quickly select the options here. I'll switch the backbone to something else because I'm feeling brave again. And I'll kick off this experiment. Hopefully this one doesn't crash. I have proof that this is a live demo now. So what I've done now is I've gone through those not master settings. I went through the novice settings, which already suggested some good opinions, and some defaults were selected. What this allows you to do is, if you really want to handhold the model, and let's say you're probably building 1,000, more than that models every day, every week, you can really select what you want to build, and you can handhold the process. You can figure out what's the best possible accuracy you can squeeze out for your use case. Now, if this did not crash, which it did not, you'll start seeing the insights already. So I can see that the learning rate is being changed with every step, so every iteration. And I can also monitor the batch loss from here. How's my model doing? If this graph was going up, I would have liked to stop this experiment, but it looks like it's going in the right direction, so we'll let it run. And as this happens, I can also see the train data insights. So I can see the flowers that are being predicted as whatever class they're being labeled to. So this is daisy, this is tulips. I identified tulips. This looks like rose, so that looks like a correct label to me. And we can also get an insight from validation data. So we can see that the best examples were daisies for now. And this is all happening in real time. So as the experiment is running, I'm able to poke around the model in real time and see what's going on. You can, of course, wait the model to train. But as you kick these experiments off, you can always monitor what's going on. You can go back and take a look after they're done. And I can also see that the worst examples look like they're the ones where the images weren't taken properly. This just looks like grass, and I wouldn't want this in my data set. So it looks like Hydrogen Torch is doing a good task so far. So I'll leave the last few minutes for any questions, and I'll quickly also point out other problem types that we support. So in the UI, I can see all of the problem types that Hydrogen Torch currently supports. It's always being improved on. As I said, medical images have just been shipped, and it will be up in the app in just a few days, I imagine. Right now, the following image problems are supported. The following text and audio use cases are supported, and you can just kick these experiments off from this dashboard, and just inside this app, you can get all your insights. So I'll end the demo here, and I'll leave it open to questions. Thank you. Thanks. I like my shoes as well, so I'm glad someone noticed. Any plans to support generative models? I'm not sure if that's on the roadmap as of now. No, I'm not sure if that's on the roadmap. Does Hydrogen Torch use fast.ai in the backend? Not to my knowledge, but we do use tricks very similar to FastAI. So FastAI is one of my favorite open source frameworks. And I think a lot of the tricks that I personally learned in FastAI, you could have seen those in the UI as well. So differential learning rates, doing different test time augmentation, all of that is supported really well in Hydrogen Torch. So whatever you learn from FastAI should be visible there. What if we would like the model to detect the gender of the person rather than fashion? Now this becomes a ethics discussion which is hard to solve in 2 minutes that I have remaining. But you would need a labeled data set for that, and I wouldn't go into the ethics of should you try to build a model or should you go in that direction. But we support data sets with labels. Someone says, hello back. How do you explain the difference? I'll skip the next one. Do we need GPU to run Hydrogen Torch? Yes, you do, but you can also sign up for our AI cloud, and you get a free 14-day trial. On there, we give you GPU instances where you can run these examples. So you get 14 days of unlimited playtime in a sense with Hydrogen Torch. How does interpretability work over ensembles? For Hydrogen Torch's use case, we're giving you validation insights and similar things, which isn't affected by ensembling. But for our other products, we have actually worked closely with experts and built that in really well with driverless AI and all of our products. So that's something that we really care about, giving you very accurate models, but also giving you insights over interpretability. So it's possible to also make interpretable models with ensembles. But as you can imagine, with simpler models, it's more easy to poke around and get insights from them. How large do the data sets need to be and the models are pre-trained? Yes, the models I downloaded are pre-trained models from ImageNet. And for data sets, it really depends on your constraints. So we support multi-GPU. And if you have a large enough instance with large enough data set or data drive, you can kick off any experiment that you could possibly think of. We're almost out of time, so I'll take the last question, which is it capable of image captioning? Yes, we allow semantic segmentation. So you could build a model on top of that if you'd like. I'm over time, so I'll end here. Thanks everyone.